In this video, we're going to revisit the cost estimation for 3C for a third time and illustrate the problems associated with multicollinearity. If we recall from our multiple linear regression model, we had tried to use direct labor hours as well as repair hours to predict our total overhead cost. We found that repair hours didn't add much to our model in the presence of direct labor hours. So we've gone out and grabbed or accumulated some other data. We have at hand direct labor cost data as well as direct labor hours. So we're going to run a model trying to use both of these variables to estimate our overhead costs. And in doing so, we'll illustrate problems associated with what we call multicollinearity. Go ahead and use Excel's functions for calculating the intercept, slope, and R-square for simple linear regression models using direct labor cost and direct labor model hours. When we do so, we can find that we can explain 62.8% of the variability in our overhead cost using direct labor costs, and we can explain 62.9% of our overhead cost using direct labor hours. Notice they're both about the same, which isn't surprising since labor hours often drives or is closely related to direct labor cost. If we had to choose one, we would pick direct labor hours because it is explaining slightly more of the variation. It's this close relationship, though, between direct labor hours and direct labor costs that gives rise to our multicollinearity problem that we'll take a look at in a minute. Go ahead now and use Excel's data analysis tool and run a multiple linear regression using all 24 months of data. Again, be sure to select labels and print your output to cell C60. Let's first pick up once again our slope coefficients for direct labor dollars and direct labor hours from our simple linear regression results up above, and they were 3.66 and 74.52. Let's go ahead now and pick up our slope coefficients from our multiple linear regression model. For direct labor dollars, it's 68 cents. For direct labor hours, it's 60.67 cents per direct labor hour. Let's pick up our standard errors. Standard error for direct labor dollars, 11.06, which means our t-stat is going to be close to 0. Let's go ahead and calculate that. Again, we take our slope coefficient and divide it by our standard error, and we get 0.06, which is what we have in our regression output. And the p-value associated with that is 95%. There's a 95% chance that this result is just, basically there's no chance at all that the real slope coefficient is different than 0. It certainly isn't 0.68, and we can see if we have a standard error of 11 and our estimate is 0.68, that's within one standard deviation, a fraction of a standard deviation from our null hypothesis that the slope coefficient is 0. Let's go ahead and take a look at our direct labor hours. The standard error, 224, and again, given our estimate, this gives us again a very small t-stat. Slightly bigger, but not much, 0.27, and a p-value of 78%. So we wouldn't want either of these variables in our model, at least not in the context of a multiple linear regression model, because neither one of them is significant at all, as evidenced by their high p-values or low t-stats. Let's take a look and see what's going on. Both variables on their own seem to have a lot of explanatory power. Why is it that when they're combined in the model, they have very little explanatory power? To examine this further, I want you to run the data analysis and multiple linear regression a second time. This time I've made one change to our data set. I've changed the number 800 from the first run to 1,000 in the second run. So go ahead and run your analysis for a second time. When we take a look at our analysis from the second run, we see some strange things going on. Well, first we can observe the p-values didn't change much at all. In fact, if anything, they might have gotten slightly worse. but we're going to see very large swings and changes in our slope coefficients. In fact, the relationship now between direct labor cost and total overhead cost is negative. And the estimated coefficient for direct labor hours has more than doubled. So the question is why? Why did our 0.68 change to a negative 3.3? Why did our 60 change to a 140? And the answer is multicollinearity. Multicollinearity causes two basic types of problems. The first problem is that the coefficients that we estimate can swing wildly based on other independent variables in the model. And we saw this swing from 68 cents to negative $3.30, which doesn't really even make a lot of sense. And second, multicollinearity reduces the precision of our estimated coefficients, which of course weakens the statistical power of our regression model. And we see this in the very monstrous p-values. What exactly is multicollinearity? Well, multicollinearity occurs when we have two independent variables that are highly correlated in our regression model. And as I noted earlier, we would expect a high degree of correlation between direct labor costs and direct labor hours. In fact, we can put together a brief correlation matrix using Excel. Go up to data analysis, and we can correlation, okay, and we're going to pick direct labor dollars, including the data label, and we're picking up our direct labor costs, including our data label, and our data is in columns. We want to have labels in the first row, and let's put that output right here in cell I-104. There's our correlation matrix, and we can see there's a correlation of 99.99%. We could see the same thing if we did a simple scatter chart. So highlight, insert, scatter graph, and there it is. We can see both variables plot along a straight line. Both variables are basically providing the same information. So a slight change in one value shifts the weight significantly from one variable to the other variable. Generally, any correlation between independent variables of more than 70 or perhaps 80% can create some slight multicollinearity problems. This is a topic that is much more advanced than anything we need to or can address in this course, but keep it in mind.